Running a 32B model locally on a $599 Mac is not a hobbyist trick anymore. It is a genuine alternative to cloud subscriptions, and the full stack is now a 2-command install. The question is not whether it works. The question is whether you can afford to keep paying someone else to run AI for you. Here is what the whole thing is made of. 3 pieces, all open source, all free. The first is Ollama. Think of it as the engine. It's an inference server that loads a model into memory and runs it. And the important part is that it speaks the OpenAI API out of the box. So anything built to talk to OpenAI can talk to Ollama instead, with a single line changed. You install it, you type Ollama run quen, and a model downloads and starts answering. That's it. The second is Open WebUI. Ollama by itself is a terminal. Open WebUI is the face, a browser chat window that looks and behaves almost exactly like the paid assistant you already use. Conversation history, system prompts, file uploads, a drop-down to switch models. You point it at Ollama and you've basically got a ChatGPT alternative running on your own box. No account, no login, nothing leaving the machine. The third piece is the model itself, and this is where the last 3 years did their quiet work. Open-weight models now ship in a format called GGUF, a single packaged file, quantized, ready to run on normal hardware. HuggingFace hosts well over 100,000 of them now. A few years ago, that number was around 200. So the catalog of things you can actually download and run at home went from a curiosity to a warehouse. And the reason people are pouring in is friction disappearing. Ollama's monthly downloads have exploded into the tens of millions. That's the shape of the whole story. Not a model release, a collapse in how hard this is to stand up. So that's the what. Now here's why it runs at all on a machine you can afford. A raw frontier model is enormous. At full precision, a 32 billion parameter model wants well over 100 gigabytes of memory. No consumer machine touches that. The trick that makes local AI real is quantization. Quantization means squeezing the numbers a model is made of down to fewer bits each. Instead of storing every weight at 16 bits of precision, you store it at 4. The model gets roughly 4 times smaller and barely loses accuracy on most tasks. Take that same 32B model and quantize it down to what's called Q4. It drops to under 20 gigabytes. Suddenly it fits in memory you can actually buy. That's the entire reason any of this works on hardware that costs less than a used car. There's a second trick worth knowing, because it's showing up in the best local models right now. It's called mixture of experts. Take a model with 30 billion weights sitting in memory. For any single token, it only lights up about 3 billion of them. You get the quality of a big model with the compute bill of a small one. It loads like a 30B and it runs like a 3B. That's how a MacBook with enough RAM ends up serving something that punches near the frontier. Put those two ideas together and the ceiling has moved dramatically. Take one of today's strong local models, Quen's 32B, running entirely on a local Mac. On MMLU, the standard broad knowledge benchmark, it lands within a few points of a top cloud model right now. A couple of points, on your own desk, for $0 a question. The gap that used to be a canyon is now a ditch you can see across. So the software fits, and the quality is there. The real question everyone actually asks is, what do I need to buy? Let me lay out the ladder. Start at the bottom, because the bottom is better than people expect. The base Mac Mini, the cheapest one Apple sells, is a completely legitimate entry point. It runs about $600 right now, and yes, it will run a 32B. That's the promise in the title, and it's literally true. Quantization is the reason, pushed a step harder. Drop that 32B to a rougher setting, and it squeezes down small enough to slip under the 16 gigabytes the base machine ships with. It loads, it answers, it costs nothing. Be straight about the trade. It's slow, a handful of tokens a second, and you've paid for the fit in some quality. The $600 box runs a 32B, it just doesn't run it fast. What it does without any compromise is the 7 billion class. Here's the thing nobody wants to admit. A good 7B handles the large majority of everyday dev and knowledge work. Quen's 7B holds its own on the benchmarks and runs a few times faster than its big brother. For summarizing, drafting, rewriting, answering questions against your own files, that machine is genuinely enough. Step up one rung and you get the same 32B without the compromise. A Mac Mini kitted out with 64 gigabytes of unified memory is the sweet spot. It runs somewhere around $1,400 today. That machine holds the full 32B model at full quality and speed, the one scoring within spitting distance of a frontier cloud model, generating text faster than you read. One payment, and you own a model that would otherwise cost you every single month to rent by the token. There's a faster path for that same 32B if you want it, a gaming GPU. NVIDIA's cards chew through the smaller models several times faster than the Mac. But that speed comes with a bill the spec sheets hide. It's the wall socket. A high-end card can pull roughly 10 times the power of an Apple Silicon Mac doing the same work. Run it all day and it adds real money to your power bill. Over a year, that starts eating the savings you came for. And there's a ceiling. A consumer GPU tops out at 24 gigabytes of memory, which caps the model size it can hold. The truly large models need far more than that, no matter which card you buy. Apple's unified memory is the quiet reason a small, cool, cheap-to-run box can load a model the GPU can't fit at all. That's why the Mac stays the spine of this build. Owning the engine has a price. Whether it's worth paying comes down to one number. Cloud inference is priced per token, and the frontier is not getting cheaper. Today's top models charge in the tens of dollars per million output tokens, and that price holds or climbs as the models get more capable. The cheaper tiers add up fast too once you're actually building. Here's what that means for a real workload. Point an agentic coding setup or a document pipeline at a frontier model, and the tokens fly. You can burn 10 million output tokens in a month without trying. At today's rates, that's about $300 a month. Every month. Forever. Local inference is $0 per token. Not cheap. Zero. After you've bought the hardware, the marginal cost of the next million tokens is the electricity to generate them and nothing else. That reframes the whole purchase. That Mac we just talked about, set against a $300 a month API habit, pays for itself in a matter of months and then prints savings. A gaming GPU is roughly the same story. But be honest about the other end of that curve, because this is where the hype gets people. If you're a light user paying $20 a month for a chat subscription, an expensive GPU takes years to earn back. Years. The hardware only makes financial sense when your usage is heavy, when you're an actual builder running agents, batch jobs, and automation that would otherwise rack up token bills. The math is entirely about volume. High volume, local wins fast. Low volume, just keep your subscription. There's no shame in that answer. The money case is real for the right person, but the setup guides skip a few things, and you need to hear them. Local models are not frontier models, and pretending otherwise is how people get burned. The honest number is that a good local model gives you 70 to 85% of frontier quality. That last chunk matters. Complex multi-step reasoning, synthesizing a long document, the hardest edge of a coding problem. That's exactly the slice where a local model stumbles and a top cloud model doesn't. For the bulk of your work, you won't feel the gap. On the hard stuff, you will, and it'll be sudden. Quantization has a floor too. Squeezing a 32B model down to fit inside a 24 gig GPU might mean dropping to a harsher compression than Q4, and that costs more quality than the benchmark headlines suggest. MMLU is a knowledge test. It doesn't fully capture how much a heavily quantized model degrades on reasoning or code. So test the quantization level you're actually running, on the tasks you actually do. Two more things the guides gloss over. First, privacy is not automatic. It's a discipline. Yes, everything runs on your machine by default, but the moment you want to reach it from your phone and you expose it through something like a Cloudflare tunnel, you've reopened a network door. Nothing leaves your machine is true only as long as you keep it that way. Second, licensing. Most of these models are free for you, full stop, but the licenses have ceilings. Meta's Llama restricts use above hundreds of millions of monthly users, and Qwen has its own cap. If you're a solo builder or a small team, that's a non-issue you'll never hit. If you're planning to embed a model in a product at massive scale, read the license before you ship. If that's you, this is the paragraph that saves you a lawsuit. Nobody in a setup tutorial will tell you that. So that's the ceiling. Here's why builders live with it anyway. None of that sinks the case. It sharpens it. Run local for the 80%, keep a cloud key in your pocket for the hard 20. That hybrid is the actual winning move for most builders, and Ollama has quietly made it trivial. It now does web search and hosted models alongside your local ones, so the line between local and cloud is a config choice, not a wall. And here's the last piece, the one that turns this from a chat toy into a workbench. Because Ollama speaks the OpenAI API, it drops straight into the tools you already code in. Continue inside VS Code, and the coding agent front-ends like Claude Code, Codex, and Copilot CLI all point at a local model with one change to a base URL. Free AI coding, running on your own silicon, with no per-token meter ticking while an agent loops. That's the moment ownership stops being a hobby and starts being infrastructure. The day you stop renting the thing you use every hour of every workday.